We left off, when was that, Tuesday? Seems like it was a long time ago. We were talking about antibodies and antibody structure. And see, we drew our nice little antibody that's composed of two light chains, which are about 200 amino acids long, and two heavy chains, which are about 400 amino acids long. And they're held together by disulfide bonds. At the ends of each of these chains, there are variable regions. And then the rest of the chain, the part that I did not color in, is the constant region.
So the constant region on the heavy ones goes all the way down?
Goes all the way down to the bottom, yes.
This was on one of the homework ones, right?
It was. So the variable regions are the regions that attach to the antigen, so they're specific to the antigen. And then the constant regions determine what class of antibodies it is. Today we're going to take a look at the antibody classes. And the classes determine how the antibody works and where it's found. So on Tuesday we used the analogy of a key. If we take a look at a key, if we look at the base of the key, we know it goes to a house or a car or maybe a Duchenne classroom. But for instance, with my car key, presumably because of the variable region, it only will open my car and only will start my car, not any other VW Beetle that's out in the parking lot or around town. Josie's having gravity issues.
So well. That's the one nice thing I did today.
Check it out.
Yeah.
All right. So you can tell what kind of key it is based on the constant region. We can tell what kind of antibody it is, what class of antibody, and then the variable region tells us the specific antigen that it will attach to. All right, so let's take a look at the antibody classes. And there are 5 major classes of antibodies. So we will start with IgD. Ig stands for immunoglobulin. Immunoglobulin. Here, I'll put it in. Sure.
Oh, so they're all the IG.
They're all Ig something.
People watching.
So IgD travels by itself. And it's usually attached to a B cell.
Sorry, does the D stand for anything?
No, it does not. It's a surface receptor on the B cell.
Wait, it has a surface receptor on the B?
It is the surface receptor on the B cell. So this is how the B cell will attach to the antigen. So in the bigger scheme of things, this is important in activating the B cell,
How the B cell will attach to
the antigen. So it's important in activating the B cell. Remember we talked about on Tuesday that when the B cell is activated, it starts cloning. When it attaches to the antigen, it starts cloning. And then produces either plasma cells or memory cells. Clubs. IgM. We have to make them feel at home when they're listening to this, right?
Oh, I had to make them feel at home. Oh.
IgMs. IgMs travel in groups of 5.
Gotta see my disgusting compost bucket.
Oh my god. You're on recording.
Oh, I'm so sorry. Hi, everybody. I'll leave now. Sorry.
I'll take your word for it.
You don't get to see the disgusting compost.
Guys, it was so gross.
Whoa, what was that in there? Dead bird?
At least
Alright.
they composted it.
So they form a pentamer.
How do you spell pentamer?
P-E-N-T-A-M-E-R.
Oh my god, I got that right. It's a pentimer. That's what I was going to say, but who cares?
Okay. So these can be found either attached to B cells or free in the plasma. If they're bound to the B cell, they serve as antigen receptors. These are the first antibodies that are released by the plasma cells in the primary response. So remember, the primary response occurs the first time a B cell comes in contact with that antigen. So these are the first ones that are released. IgG. These are the most abundant antibody in the plasma. In the plasma. Most abundant. They are the main antibodies in both the primary and secondary response. We will talk about a little bit later on today about ways that we acquire immunity. And one way that we acquire immunity is by IgG passing through the placenta when we are a fetus. So this is our first third line of defense that we ever have. First third line of defense.
So like when it passes through, it like is the first development.
Yes. This would be our first immune system because we get it while we're still a fetus. Thank you, Mom. IgA. Some of these are found as monomers in the plasma, so just single antibodies in the plasma. Some of them are found as dimers, so two of them bonded together. In secretions. So things like saliva and tears and milk. So this is another defense that you can get from mom if she breastfeeds, which is one of the reasons why we say breastfeeding is better than formula feeding, because in the formula you're not going to get that added line of defense that you get from breast milk. And the final class are the IgE. These are found in the secretions of the skin and mucosa. These particular antibodies trigger the release of histamine and other chemicals that cause inflammation. And they are largely in charge of allergic responses. When we have disorder day on Monday, our first disorder is allergies.
We love disorder day.
Best day of the chapter.
Yes. Oh, hi there.
All right, so what exactly do these antibodies do? I mean, we talked about with IgE that it causes inflammation, it triggers inflammation, but what exactly are they doing? So when an antibody binds to an antigen, we call this an antigen-antibody complex. And this causes a series of reactions. It causes neutralization of the antigen. By masking harmful parts of a bacterium or virus. It causes neutralization by masking the harmful part of a bacteria or virus. It can cause agglutination. We've used this word before when we talked about blood typing and mismatching of blood types. Okay. This is where the cells become sticky and kind of clump together. And as part of this, they cause precipitation. Now think back to your chemistry days. When you put two liquids together and you got to precipitate, how did you know? It dropped to the bottom, right? That is what you said. Yeah, it drops to the bottom. You put two liquids together and you end up with a liquid and a solid, okay? Well, when they're agglutinating and they're sticking together, we're getting these big clumps. They're more dense than the blood, and so they're going to precipitate out.
So they just kind of like sink and sit there.
Well, and then the phagocytes come along and eat them. But it makes it easier for the phagocytes to eat them. It makes it easier if there's a large clump than if there's just one single little antigen there. The last thing that the antigen-antibody complex can do is it can cause complement fixation. So those first three, the combination of neutralization, agglutination, and precipitation, enhance phagocytosis. You have to go back to the second line of defense to remind yourself what complement fixation is, but with complement fixation then enhances phagocytosis, inflammation, and leads to cell lysis. So all of that, starting with the antibodies, starting with the B cells making plasma cells, memory cells, plasma cells make antibodies, all this antibody stuff, this is all humoral, the humoral branch of immunity. The other branch is the cellular immunity. So recall that cellular immunity is mediated by the T cells. And remember also we talked about that the T cells will not bind to a free antigen. They need the antigen presented to them. By those APCs, those antigen presenting cells. And there's all sorts of those, and so, you probably saw some of those in working on your assignment for today. So there's like Langerhans cells, macrophages. We usually talk about macrophages the most. There's the dendritic cells, or maybe you'll see that. And so it begins the same way as with B cells when they attach to a free antigen and they start cloning. T cells do the same thing when the antigen is presented to them. They start cloning. And they make a variety of different, their clones differentiate into a variety of different cells. We're going to take a look at 4 of them. But these are not the only 4 that are out there. These are the 4 most common. So types of T cell clones. Cytotoxic T cells, more commonly known as killer T cells. Killer T cells specialize in virus-infected, cancer, and foreign graft cells. These are the guys that bear a resemblance to the natural killer cells, except these are antigen specific. Natural killer cells are not. Killer T cells release a toxic chemical called perforin. And perforin wears away at the cell membrane. And when it does this, then, it's going to allow water to enter the cell, and it also allows granzymes to enter the cell. And granzymes are just enzymes, they're protein-destroying enzymes.
Are those released by the T cells?
They are. They're released by the T cells, so it allows these protein-destroying enzymes and water to enter the cell, so that's going to kill the cell. And like the natural killer cells, they attach to the foreign cell. Let's say a bacterial cell, they attach to the foreign cell and start releasing this perforin, and then release their granzymes and then take off. So by the time the cell dies, they're long gone. Helper T cells. The helper T cells are kind of the managers of the immune system. Once they are activated, they wander around the body, recruiting other cells to help fight the foreign invader. So they do things like enhancing the cloning of B cells.
They what? Sorry.
Enhance the cloning of B cells so that we can get some more antibodies made. They stimulate killer T cells to divide. They enhance the ability of macrophages to phagocytize, so to engulf and destroy, phagocytize. And then they also attract other types of white blood cells to the affected area. So they're enhancing the immune system. Another type of T cell, the regulatory or suppressor T cells. these release chemicals that suppress the activity of B cells and T cells. So they're suppressing the immune system after this foreign invasion has been defeated. And so this is going to stop any unwanted activity, immune activity. And the final type of T cells that we're going to talk about are memory T cells. Okay, so once again, providing memory for future invasions, just like the memory B cells. So in comparison to how much time we took to talk about the humoral immunity, that's it for cellular immunity. No, that's just it for cellular immunity. Well, we're almost done. We don't have a whole lot more for today. One last topic before we get to disorder day on Monday, and that's acquired immunity. So there are 4 different ways that we can acquire immunity. We can do it, and so we'll kind of mix and match, and I have more on my outline up here. But so we can do it naturally or artificially. And within each of those, we can do it passively or actively. So I've broken these down first into naturally and artificially, and then within each of those, active and passive. So naturally acquired active is when we are invaded by a bacteria or virus and we see the symptoms of it. So basically, when the first time you come in contact with something you have not been in contact, a pathogen, antigen that you have not been in contact with before, and what does your body do? It builds memory. And so you have acquired an immunity to whatever that antigen is. Naturally passive, we mentioned a little bit earlier today. This takes the form of the antibodies that pass through the placenta. The antibodies that pass through the placenta. And then also those antibodies in mother's milk. So your immune system isn't actively forming a memory, you're just getting those antibodies directly from your mother in one of those 2 ways or both. Artificially, so once again, with active, it has to be something that where your body is actively producing a memory. So to artificially actively acquire immunity, that's what vaccines are about. vaccines are dead or attenuated forms of the pathogen. Attenuated means weakened. So their presence is enough to cause an immune response, but so you are building a memory, but they're not strong enough to cause an immune response that's going to make you sick, make you show the symptoms. But you've got the memory. Artificial passive is when you get donated antibodies. Now, this usually, you usually get this after you've been exposed. And what these do then is they give you a borrowed immunity. They usually only last about 2 or 3 weeks, but they give you a borrowed immunity until your immune system can kick in.
So it's after exposure to like an antigen?
Yes. So this would be things, so for instance, hepatitis, after you're exposed to hepatitis, they can give you this borrowed immunity. You can use it for things like rabies, or let's see, antivenoms for snake bites would fall into this category as well. All right. And that leads us to disorders.